Good afternoon, guys. How are you all? Hope you people enjoyed your weekend. Yeah. Okay. Yeah. Yeah. Good afternoon, everyone. Good afternoon. Okay. Okay, guys. Fine. I think this is the strength. We'll just start today. Okay. We'll just start today early and we'll try to complete the things. Okay. Let me just share my screen just a moment. Okay. We'll just wait for another 3 minutes. Okay. Last 3 minutes we'll wait and we'll start the session. Today we'll discuss about the T test, Z test, chi-square test, F test, and ANOVA test. Okay. All these tests we'll be discussing. Okay. All these tests we'll be discussing, and I have created a handbook for that also. Okay. We'll be uploading those handbooks, and I have seen that some of the people are unable to access the links, but whatever the files which have been explained, I mean, whatever the notebooks which have been used for explanation purpose, all the notebooks have updated in the Google Drive link. Okay. So please go through those things. It is very helpful. Okay. And we'll just wait for another 3 minutes. Then we'll immediately start the session. Okay. And in the meantime, if anyone is having any doubts, please post your doubts in the Q&A chat. Okay. Thank you. Nandini, only you need to do the mock assessment. The peer assessment is not required. Okay, it's just for knowledge purpose. Okay, knowledge gaining purpose. Is that clear, everyone? In the digital STEM course, you can do the mock assessment, but coming into the peer assessment, don't do that. Okay, it's just for knowledge purpose. Okay, thank you. I'll confirm you regarding that. Okay, no worry, Nandini. Okay, I hope this is the strength. I'm sharing my screen. And whatever the other queries you're having, please keep the queries to you. We'll be starting this small session, okay? And I'll be asking few questions. Please answer me along to that question, okay? Okay. So, what is the first step? What is the first step which is involved in the machine learning? In machine learning, what is the first step, guys? In machine learning, what is the first step? Okay. Data pre-proof problem statement. Yes, Srinivas, oh, correct. Problem statement. Sorry. Okay. Okay. Defining the problem statement. Okay. Defining the problem statement is the first major step. Okay. Defining the problem statement. What could be the next step, guys? What could be the next step? What is the next step? Immediately. I'm getting answers over here. So everyone please. Yeah. Data collection or data gathering. Correct. Data collection or data gathering. So what are the first two steps? Defining the problem statement, data collection and data gathering. And what is the third step over here? What's the third step? Data pre-processing. Correct. So in the data pre-processing only, the EDA will be happening, and all the cleaning, all the things will be happening. All the label encoding, feature engineering. Correct. Then what is the next step? What is the next step of the data pre-processing, guys? What are all the things we have discussed on Friday? Yeah, identifying the suitable algorithm. What is that exactly? How do we say that? Suitable algorithm means identifying the type of an algorithm to choose. So how do we say that? Model selection. Correct. Model selection. Model selection, splitting the data, training that, evaluation, testing. Correct. Remember all these steps, guys. Remember these steps. Okay. Everyone remember what is this hypothesis testing and H naught and also HA. What is HA? What is HA, guys? HA. All of a sudden, everyone stop. Yeah, alternate. Correct. Correct, Anusha. Alternate hypothesis. What is H naught then? H naught. Yeah, none. Correct, Anusha. Correct. Correct, Aparna. Yeah. So whatever the assumed data which we are having, that will be the H naught. H naught is null hypothesis. And what is HA? HA is alternate hypothesis. Correct. Alternate hypothesis. So just a moment. So yesterday, I mean on the last day, I have shared you the EDA, right? How many of you explored that particular notebook? How many of you explored that notebook? How many of you tried to explore that EDA notebook in the drive link, which I have shared in the drive link? How many of you explored it? Okay, done. Yoga Shri, Manikanta, thank you. Only few. Shaheen, Sai Kumar, no, Ganesh, why? What happened, Ganesh? Tejasvi, Dharani. What happened, Ganesh? Okay. Everyone explored it, right? Any doubts in that particular EDA file? Any doubts in the file? Doubts in the file? No? So whatever the topics which I have explained until now, is it clear each and every topic? Everyone? Ashok, it's not the correct time to ask attendance right now, please. So anyone having any doubts in any of the topic? No, right? So fine. So I'll be explaining this T test, F test, and Z test. Okay. Let me just share my screen, and after that, and someone was asking me, Sushil, right? Sushil, Sushil, are you in the session? The difference between a label encoding and a one-hot encoding. Is it Sushil or anyone? Yeah, it's fine. It's fine, Ashok. Someone was asking me regarding the difference between a label encoding and a one-hot encoding. How many of you remember this label encoding? What is this label encoding, guys? What is label encoding? Yeah, Sushil. Yeah. Well, I will say that, okay? We should not say like that, Anusha. We should say like labeling the textual data or else label encoding the textual data. We need to say in that format, okay? Label encoding the textual data. Yeah, we can say like what Jagadish said exactly. Converting text into numerical also. We can say, yeah, encoding text to category. Encoding the text into label in the format by using the label encoder. So what is the main difference between a label encoder and a one-hot encoder? We'll see that, okay? So I hope everyone is able to see my screen. So what happens in label encoder if I'm having in a column, let's say I'm having two values, okay? The column is gender, and in this I'm having male, comma, female, okay? Under gender I'm having male and female. So in label encoding, what happens? In label encoding, the same column will be converted into, if I'm having male more counts, it will be converted into 0 and 1. Correct. So coming into one hot encoding, okay? One hot encoding. In one hot encoding, what happens exactly is, let's say I'm having the same gender column, okay? Same gender, male, female, okay? Male and female. So now what exactly happens is, now I will be having this gender column, okay? This gender column I will have a male column, I will have a female column, okay? And so if it is male over here, if I'm having more values over here, it will be 0 and it will be 1, okay? It will be 0 and it will be 1. So in this way, three columns will be created. Okay? Three columns will be created. So let's say if here it is female, then if the female count is less or greater, based on that, it will be encoded as 0 or 1. Okay. So whatever the value counts which we are having, okay, whatever the values we are having, M and F, right? For M and F, a new column will be created. Okay, a new column will be created. A new column will be created, and according to that, the label encoding will be happening. If in that row, if it is male, it will be encoded as 0. If it is female over here, If it is female over here, it will be encoded as 1. Here it will be 0. If it is male over here, it will be encoded as 0. It will be encoded as 1. So this is how the one hot encoding happens. Okay. This is how the one hot encoding happens. Is the one hot encoding clear? That is nothing but one hot encoding. Okay. Is it clear, everyone? Sushil, is that clear? Exclusively, you are asking for one hot encoding from the last Friday, right? Okay, Ashok, we are discussing about label encoding versus one hot encoding. So mostly label encoding we'll be using, and depending upon the problem, we'll be going for one hot encoding. Okay. Fine. Okay. So now label encoding, one hot encoding is fine. So Sheikh will be discussing about T test, F test, Z test, and chi-square test. Okay. So anyone any doubts related to that machine learning data pre-processing steps? No, right? Fine. I'll just complete this T test, F test, Z test, and then we will dive into notebook. We'll run a notebook. Okay, we'll run the notebook, and then that is done. If time permits, we'll start with an algorithm, KNN algorithm. Okay. So let me just open this one again. So now we'll be discussing about the T test. Okay, T test. So what exactly is T test? Okay, what exactly is T test? We'll discuss. 1 minute. Okay, I'm sorry. So coming into T test. So what is this T test? Okay, T test is nothing but it will be comparing the means. Okay, it will be comparing the mean, and by comparing the mean, what it says, it will be determining if there is a difference. Okay, so the main purpose of this T test is to compare mean and determine if differences are statistically significant. Okay, differences are statistically significant. So this T test, F test, Z test, everything will be doing under the population. From the whole population will be considering the samples, and then we'll be performing this test. Okay. So coming into types. Okay, coming into types. So in this T test, we'll be having one sample T test. Okay, one sample T test. One sample T test we'll have. Okay, one sample T test we'll be having in this T test. So what this one sample T test does is compares the sample mean to a known population mean. It will be in this one sample T test. It will compare the sample mean to the known population mean. Okay, population mean. Population mean is the entire data or is the entire column population mean. Sample means considering only the sample values and doing a mean on that. Okay, doing a mean. That is about the one sample T test. Okay, that is about the one sample T test. And there is another type of the T test, that is independent two sample T test. Okay, independent two sample T test. Okay, independent two sample T test. So what it is exactly? It will compare the two independent groups. Okay, whatever the groups which we are having, it will compare the two independent groups. Compare independent groups. Compare independent groups. Okay, CAG, comparing the independent groups. The groups are nothing but again the columns. So here we are having another type, that is paired T test. Okay, paired T test. Paired t-test, okay. So what is this paired t-test? Again, it compares the mean of the same group at different times, okay. This one will compare the mean of same group at different times. So we can say like, let's say if you are monitoring the stock data, okay, stock data. So every minute we'll be monitoring, right? So if you are using this paired, we can use this paired t-test to compare the mean of the same group at two different times, okay. Compare this mean of same group at two different times, two different time zones, we can say, or not time zones, times, okay, two different times. So what exactly are these? So we have discussed this one sample t-test is nothing but comparing the sample mean to the population mean, and coming into independent two test, two sample test. Independent two sample test is nothing but compares the mean of two independent groups, right? Yeah, it compares the mean of independent groups. So compares the mean of two independent groups actually. Compares the mean of two independent groups. And coming into what is this paired t-test, right? So it will compare the mean of the same group at two different times. So what is the main difference of this the independent two sample t-test and paired t-test? In independent two sample t-test, it will compare the mean of two independent groups, and in this paired, it will compare the mean of the same group at two different time zones. Okay, I mean two different types, not the time zones. Sorry. At two different times, it will compare the same mean. Okay, right. So these are about the types. Okay, these are about the types. But when to use them? So when the sample size is less than 30, let's say sample size less than 30. Okay, the size, and this is a sample, n is a sample. So when to use this t-test? When our sample size is less than 30, this is the first point. Second point, these are important. These are mainly important. So, and when the population standard deviation is unknown, for the whole population, whatever the standard deviation is, if it is unknown, then we can use this. Okay. We can use this. So when to use this, what are all the two main key factors or two important points to use? When the sample size is less than 30, sample size less than 30 and the population standard deviation is unknown, when the population standard deviation is unknown, and when the data is approximately normally distributed. Data is approx normally distributed, okay? Approx normally distributed, okay? Normally distributed. Data is approx normally distributed. So the formula for this will be T equals to X mu by S by under root of n, okay? N. Sorry, that is n, okay? Yeah, n. Roses. So now, what are the three important factors to perform as the t-test? When whatever the sample which you are considering, when the sample size is less than 30, and the population standard deviation is unknown, okay? Population standard deviation is unknown. And also when the data is approximately normally distributed. Whenever the population is having these kind of things or these kind of features, we can go for a t-test. We can go for a t-test, okay? We can go for a t-test. So these are all like when to use, okay? We have discussed about the types, when to use. So I'll just give a sample example. Sample example, we can say like in a real time, we can say comparing the average scores of the students before and after attending a workshop, okay? Comparing the average scores of the students before and after attending the workshop. Okay, so let's say there is a workshop, and before whatever the test score they were scoring, okay, and then comparing the test score after what they are after attending the event, okay. So let's say there is an event, okay, event. Let's say there is an event happening. In this event, a test will be conducted. Test will be conducted. So all the students are participating. Before this event starting, a test will be conducted to a group of students, okay. And after the event ending, the test will be conducted. So to compare these averages, to compare these averages, or else to work on these averages, what are the types we are having? One sample t-test. Yeah, one sample t-test, it is nothing but comparing the sample mean to the known population, right? We will be comparing the sample mean to the known population and independent two sample t-test. What is this independent two sample t-test again? Comparing two independent groups, correct? Comparing the mean of two independent groups. And what is a paid t-test? Paid t-test is nothing but comparing the mean of the group at two different times. Okay. See, what is the, as per the example, we can go for the paid t-test, right? As per the example, we can go for paid t-test, right? Comparing the mean of the group, two different groups at two different times, right? So these are the types of the t-test which we can use, and that is the scenario. And when to use exactly? Whenever sample size is less than 30, and when the population standard deviation is unknown, and when the data is approximately normally distributed. How the normal distribution graph will be? This is x-y axis. This is how the normal distribution graph will be, right? So when the data is approximately normally distributed, or else when the population standard deviation is not known, or else when the sample size is less than 30. Okay. So in those scenarios, we can go for a t-test. So the real-time example I can say is comparing the test score before and after attending a workshop or else an event. Okay. Before and after attending a workshop or an event. So hopefully this t-test is fine, right? Everyone understood? When to use? Everyone understood? Thank you, Anusha. Thank you guys. So if anyone is still having doubts, you can ask me. If not, we can proceed with Z test. Okay, Z test or the Z test. Z test. Okay, Z test. What is this Z test again? So first we will discuss this purpose. Okay, the main purpose. Okay, let me just come up with an example. Okay. Okay, so let's say there is a e-commerce company. Okay, let's say there is an e-commerce company, and they will be providing us the time, right? They will be providing us, like we'll be delivering your good or else your product in 3 days, or else they'll be saying it in 2 days or else 5 days, right? They'll be promising this, right? They'll be promising this 2 days or 5 days. So we can apply this Z test when, if you want to check if the average delivery time, okay, if the average delivery time of that company is significantly different from the promised time. Okay, to check the average delivery time of the company, if it is significantly different from the promised time of 2 days. Okay, let's say they promised a time of 2 days, and whatever the time which has been promised, we will be checking the average delivery time. What is the average delivery time which is being taken by the company? Okay, so that is about this. That is the main example of this Z test. Okay, so I will explain what is Z test again. So let's say there is an e-commerce company and they were promising a 2 days delivery. Okay, 2 days or else a 5 days delivery. So now what I will be doing is I want to check. Okay, I want to check if the average delivery of that company, is significantly different from this promised time. Okay, if it is significantly different from this promised time, whatever the time is promised, whatever the time has been promised by the e-commerce company, is it same or else is it different? To check that, I'll be using this Z test. Okay, so the definition will be like to determine whether the sample mean or proportion differs from a known population. Okay, known population. Whatever the known population we are having, so known population here is nothing but the 2 days or the 5 days time period which has been promised by the e-commerce company, and we'll be determining whether the sample mean or proportion differs from the known population. Okay, sample mean average is nothing but how many the average of all the deliveries which have been delivered by the company, all the product deliveries happened by through the company. I'll be taking an average and I'll be checking that is there a change or else is there a difference in between the delivery time. Okay, that is the main purpose. Okay, in the definition format, if we want to say, we can say that to determine whether the sample mean or proportion differ from a known population value. Don't worry, I will just provide all the content which I am explaining in the format of an handout. Okay, in the format of an handout, I will be providing once immediately after we are done with this test discussion. I will provide that. Okay. So what are the types in z-test again? Z-test. Okay, Z-test or z-test we can say. What are the types here? One sample z-test we are having. One sample z-test we are having. Okay, one sample z-test, and we are having two samples z-test. Two samples z-test. Two samples z-test we are having, and also there is this z-test for proportions. We'll say okay. Z-test for proportions. I'm not having my writing pad with me, so that is the reason. Please adjust, okay? And if you're not understanding what I'm exactly writing, you can ask me in the Q&A. We'll be answering, okay? So now let's discuss about this one sample z-test, okay? Let's discuss about one sample z-test. So what is this one sample z-test or a z-test? It will compare a sample mean with a population mean, okay? It will compare sample mean with population mean, okay? Population mean. Just a minute. So comparing the sample mean with the population mean. Sample mean will be average, like the promised time, right? And population mean will be the delivery time, average delivery time taking, right? The average delivery time, whatever the delivery, whatever the goods the e-commerce company has delivered, comparing all that goods delivered time and taking the average time from that. That is the population mean, we can say, okay? So comparing the sample mean with the population mean is one of the ones. Sample z-test, what it is comparing two sample means, okay? Two sample is nothing but compare two sample means, okay? What are the sample means which we are taking? We are comparing those two samples. We are comparing the mean of those two samples, okay? So that is what the two samples z-test is, okay? And what is this z-test for proportions? Comparing the sample mean and the population proportions, okay? Population proportions is again the same thing, okay? Comparing the sample and population proportion. Compare sample and population proportions, okay? It's nothing but again comparing the sample and population. So when to use this z-test? See, for t-test, we know when to use. When to use t-test? When the sample size is small, when the data is approximately normally distributed, and the population standard deviation is unknown, correct? So when coming into z-test, when to use z-test? We need to use z-test when the sample size is greater than 30, okay? The sample size is greater than 30, and also same thing, population's standard deviation is unknown, okay? Unknown. So when the sample size is greater than 30 and the population standard deviation is unknown, at that time we can go for this z-test. So this is about the z-test, okay? It's nothing but checking the average delivery time of an e-commerce company, which is significantly, which could be or else which is significantly different from the promised time, okay? Promised time. Okay, this is about the z-test. Everyone understood z-test, t-test and z-test? T-test, z-test. Clear, right? T-test and z-test. Thank you. Thank you, Sri. Thank you. Thank you, Sneha. Okay. Yeah, for z-test also there is a formula, okay? For z-test also, Niharika, initially, today OneNote I will be using. Okay, I can use the Notepad also, but if I write in Notepad, it is taking a bit of my time. So I just use that OneNote, and whatever the things I have explained with the same examples, I will be uploading the document, and that link I will be uploading the document in the drive. Okay. So once I have done with this F test and ANOVA test, we'll go into that drive link. Okay, and I will upload the drive link and I will let you know when that is updated. Okay. Thank you, Niharika. Fine. Yeah, Shaheen, there is a formula for Z test. Okay, just a moment. Let me just open my note again. Let me open it a bit. Okay, thank you. Z test, right? So for Z test also we are having a formula Z is equals to x bar minus mu by r by root n. Okay, so this is the formula for Z test. Okay, this is the formula Oh, sorry, I was on mute and I was speaking. I just realized I was on mute. I'll just explain the F test from the start again, okay? I'll just explain the F test from the start once again. I'm sorry. I'm really sorry, guys. That was a huge mistake from my end, okay? I'm really sorry. That was a huge mistake from my end. I'll explain that F test once again, okay? Is it audible and clear now? Okay. Yeah, I'm sorry for that. I will explain this test once again. Okay. So F test is nothing but we'll be comparing the variances of the two groups. Okay, F test is nothing but we'll compare the variances of the two groups. Okay, let's say we are having two stores. Okay, just a minute, let me just undo all this. Okay, so there is this two stores. Okay, store one and store two. Okay, store one and store two we are having, and now let's say he is the customer. Okay, he is the customer. He is the customer. Okay. Fine. So let's say he is the customer now. Now, what I'm saying is this customer will be visiting to this store and he will be visiting to this store. Okay, he'll be visiting to that one store and the other store. So now what happens is the customer satisfaction scores will be collected. Okay, the customer satisfaction scores will be collected for this store and this store. Okay, for both the stores, the customer satisfaction scores will be collected, and for those stores, what happens is we'll be comparing the variance of those two groups, or else we'll be considering the samples. Okay, either we'll be considering this whole groups from group one and group two, and we'll be comparing the variances, or else we'll consider only sample. We'll consider only sample from these, and we'll be comparing the variance of these samples. Okay, either we'll compare the sample variances or else the whole group variances. We'll be calculating this. What exactly F test is? F test is nothing but comparing the variance of two groups. Okay, comparing variance of two groups. But what exactly is the variance? Variance. Okay, variance. This one we didn't discuss, I think. Variance. Okay, what is it? What exactly is variance? So it is measure of how spread the data is. Okay, so variance will be measuring how the data is spread. Okay, how the data is being spread. Like it will be telling us how far each number is from. Okay, how far each number is from the average mean, we can say. Let's say for sample we have did an sample mean. Okay, sample mean we have got. So what are the sample mean value we are having, and we'll be considering another point from the from the sample data which we from the sample observations. So we'll be calculating what is the distance between this sample mean value and also the sample observation drawn from that sample set. Okay, that is what the variance is. Okay, the distance between them, telling about that. And also if the numbers are close to the mean, the variance will be small. Okay, numbers are close to mean, the variance will be small, and if the numbers are more spread out, the variance is large. Okay, so it is like I'll say one example for variance. Okay, so if the scores of the students in one single test, okay, let's say scores of a student in one single test are all around 180. Okay, the average I'm considering is 80. The average mean I'm considering is 80. And if the scores of all the people are lying around the 70 to 80 or else 60 to 80, the variance will be low. Okay, the variance means the spread out. Okay, how the numbers are being distributed, or else how the numbers are located at that spread, will be saying it as a variance. Okay, and let's say uh, considering the same average as 80, considering the same average as 80, let's say some of the students have scored 35, 50 or a 60. Okay, then at that time the variance will be high, because when considering the average mean, when considering the average of the whole population, how the data points are spread out when compared with that sample average. Okay, that will be calculating, and that will be deciding as a variance. how the data points are spread out is known as the variance. Okay, data points spread out. This is for variance. Okay, so what is the real life example we have considered for this variance? Comparing the variability in customer satisfaction score, right? Like between two branches or else between two branches or else two different stores, we can say. Okay, so the formula will be and one more point, when to use this, right? When to use this? So we can use this like before performing the t-test. Before performing the t-test, okay, what is t-test again? T-test. T-test means the sample size is less than 30, the population standard deviation is unknown, and the data is approximately normally distributed. Okay, the data is approximately normally distributed. So that is about the t-test. So before performing the t-test, we can go for this f-test. Okay, in this f-test, there is this formula, and the formula is f is equals to s1 by s2. Okay, s1 by s2. S1 is nothing but the variance of the first sample, and S2 is nothing but the variance of the second sample. Okay, variance of first sample, variance of second sample. Okay. Okay, so this is about the F test. Okay, is F test clear, guys? Is it clear, guys? Thank you. So I will just ask a question now. Okay, I will just ask a question. So if my sample size is less than 30, okay, small sample size, what test I can go for? What test I can go for? T-test. Okay, T-test you are saying. So what are all the other parameters I need to consider in order to go for T-test? What are all the other parameters I need to consider? Yeah, the population standard deviation is unknown. When the population standard deviation is unknown, correct. And also, what is the other point? And data will be approximately normally distributed, correct. So now, in which kind of test the sample size is greater than 30? Z-test, you say. So z-test formula, in this z-test formula, we'll be having this x bar, right? X. In the formula, we are having x, right? What exactly is x? Not f-test. It is z-test, okay? I'll share my screen. Yeah, it is sample mean, okay? It is sample mean. So mu, what is mu? Let me just display the formula. Mu is again the population mean, right? Mu is again the population mean, right? Fine. So everyone understood the difference between f, t, and z. When to use f and when to use t? When to use f? Let me just show this. Stop sharing. Now let me know when to use t. When to use t? When the sample size is less than 30, and also when we want to compare the test scores, or else when we want to compare any particular values before happening that event, and also after happening that event, correct? Before occurrence of that event and after occurrence of the event, based on the results, we will be comparing those two means. Okay, those two means, and we need to make sure that the sample size should be less than 30. Then we can go for t-test, correct? Then we can go for t-test. So coming to z-test, what we can do in z-test? remember the example of remember this example of this e-commerce company which I told. E-commerce company. For which example I have told e-commerce company? I mean, for which test I told e-commerce company? Okay, n greater than 30. Okay, fine, fine. No, yeah, for z test I told, correct. Also, f test we have discussed, right? So, yeah. Standard deviation is nothing but under root of variance, as you people know. Fine. Okay. So now, yeah, thank you. So I got, hopefully everyone understood this test, right? T, F, F, Z, right? T, F, and Z. Everyone understood, right? Okay. Fine. Fine. Thank you. So now, what we'll be doing is, we will discuss about ANOVA, okay? ANOVA, we can say. We'll discuss about that ANOVA test, and then we'll take a short break. Then we will dive into that notebook implementation part, okay? Notebook implementation part. And through live, we will implement, we'll take one small notebook and we'll try to implement the things, okay? In live. All data pre-processing only. Fine. Thank you. So whatever the examples I'm using, whatever the things I'm saying, exactly you will be provided in the handbook, okay? So don't worry, okay? Don't worry. Thank you. Yeah, my voice is. Anyone know what is ANOVA? ANOVA, okay? ANOVA. So what exactly is this ANOVA? ANOVA is nothing but analysis of variance, okay? Analysis of variance. So analysis of, sorry. So analysis of variance, please everyone write, okay? Analysis of variance, okay? Analysis of variance is nothing but ANOVA. So the main purpose of this ANOVA is nothing but to compare the means of 3 or more groups, okay? Compare the means of 3 or more, okay? 3 or more. More groups, okay? Compare the mean of 3 or more groups. Compare the mean of 3 or more groups. ANOVA will be very simple, okay? See, if you are having 3 or more than 3 groups or more group, more groups, so to compare all those group means, we can use this ANOVA test, okay? We can use this ANOVA test, and the types here in this ANOVA test are we'll be having one way ANOVA and two way ANOVA, okay? One way and two way, okay? One way and two way. One way ANOVA, two way ANOVA. One way is nothing but one independent variable, okay? One independent variable we'll consider. Okay, two way means we'll consider two independent variables. So similarly, if you are comparing the mean of 3 or more groups, we'll consider those independent variables, and as per that we'll be doing the test. Okay, as per that we'll be doing the test. Okay, so here we'll be having this types like mean square between the groups and mean square within the groups. Okay, we'll be having this mean square. Okay, mean square, it will be between the groups, between groups, and also within the groups. Okay, within the groups we'll be having what we'll be having mean square. What are the mean that will be what are the mean which we are getting? We'll be doing the mean square between the groups we'll be doing, and within the group also we'll be doing. Okay, so then the formula will be F is equals to MSB. Okay, MSB is nothing but mean square between groups. MSB is nothing but mean square between groups, followed by mean square within groups. Mean square within groups. Okay, we'll be having whatever the groups we are having for each and every group. We'll be calculating and we'll be doing the mean square by comparing all the three means and also by comparing the means within each group. Okay, between them and within them. Okay, fine. These are all fine. But when to use it exactly? When to use it exactly? So we can use this to test if at least one group's mean is different from other. Okay, to test at least. Sorry. So to test at least one. I mean there is this one group. Okay, one group. Okay, for this one group, how did I mean? Okay, I have calculated mean for this one group. Okay, for this one group, I have calculated the mean. So in order to test this mean is different. That mean is completely different from other group mean. Okay, in order to test if this one group mean is different from other group mean, we can use this ANOVA test. Okay, we can use ANOVA test. And one of the real-time example I can say is comparing the score. Okay, comparing the score of the students from three different teaching methods. Okay, from three different teaching methods, comparing the average score of the students. Okay, comparing the average score of the students from three different teaching methods. This is about ANOVA. Okay, so ANOVA will be using when to compare the mean. To compare the mean between the groups. Okay, to compare the mean between the groups, or else to test at least one group mean is different from others. Okay, so in this time we'll be using this ANOVA. Okay, so the formula for ANOVA is MSB, that is mean square in between the groups by mean square within the groups. Whatever the groups which you are having, let's say if you're having one group, I mean one single variable, we will say as one way ANOVA. If you're having two, we'll be saying it as two way ANOVA. If you're having three, we'll be saying it as three independent variables. Okay, three way ANOVA, three independent variables. So this is about the ANOVA, F test, T test, and Z test. Are all this clear, guys? Is this clear, everyone? Okay, guys. So fine. Thank you. So after the break, we'll do that EDA exploration. Okay, EDA exploration we'll be doing, and I'll be updating this handbook directly when we are done with chi-square test. Okay, we'll also discuss chi-square test. Okay, we'll just have a short break. We'll just have a short break, and in the meantime, the attendance link will be updated in the chat. Okay, so I don't want no one should update that their attendance screenshot. Okay, once you have filled the form, that's it. Okay, don't upload that screenshot in the chat. Okay, please don't upload the screenshot in the chat because others will not be able to get that particular link. Okay, so let's have a 10 minutes of break, and in the meantime, please drop your attendance. Thank you. Okay, I hope everyone are done with attendance and everyone is back, right? I'm sorry. Yeah. Everyone is back, right? Is my voice audible and clear now, Chindu? Okay. Everyone done with attendance? Everyone is done with attendance part, right? Okay, fine. Okay, okay. Thank you. Thanks for confirming. So now we'll just implement the notebook. Okay, we just implement the notebook now. Let me just share that screen. Okay, just a moment. Just give me a minute. So guys, this FIFA is done, right? FIFA, bank chain data, and the practice ADA part. All these things are done, right? Everyone explored all those three data sets. Everyone explored it, right? Okay. 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 So now you people answer me. What is this bivariate analysis? What is bivariate analysis? Bivariate analysis. What is bivariate analysis? Okay. Guys, what is bivariate analysis? Two columns. Thank you, Agneshree, Manisha. Okay. 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 Fine. Okay. I just got only few responses. Everyone forgot about this exploratory data analysis. Remember, right? Examining how things are related. Okay. Relationship between two variables, not exactly Lakshmi. Data analysis of two columns. Good one, Aparna. Good way of explaining the things. So, I'll just open a notebook. Just a moment. I'll just open a notebook. Okay. Coming here, let me just open my notebooks, the other notebooks. So let's say activity, lifestyle data, or else let's take the just a minute. Let me just open any one of the notebook and I'll share my screen directly. Give me a minute. Card data. Just go with yeah, card data challenge. Fine. So card data challenge. I'm sharing my screen. Okay. Just a moment. Yeah, I'll be sharing my full screen. Okay. Full screen. See, these are the notebooks which I have worked long back. Okay, I have divided the things into task wise. Okay, I have divided the things into task wise, and I have worked on these notebooks. I'll just share these notebooks with you. Okay, just a moment. Okay, so initially this is a notebook which I am having, but to make sure all the things are running well and good, I need to connect it, right? So I'll just connect, connecting. And let me just connect it to my drive. Connect to drive. So I need to run this cell in order to connect to drive. So I run this cell. Now I need to give the permissions to connect. Yeah, and I want to connect by using this email ID. Okay, and I need to press on continue. And then I need to give access. Continue. Then the drive will be mounted. Okay, then the drive will be mounted. And once I just got my drive, once this this cell I have, if I see a green tick, then it's fine. Okay, yeah. Now I can comment out this cell. Okay, no need to run that. So here I got this new folder called drive. So whatever the drive content Excel files I'm having, I will be having over there. So just a moment. Okay, so I have connected to my drive, right? Let me just open the drive content and my drive content. In the my drive content, I'm having AML content. Okay, in the AML content, I'm having Python for data science. Okay, Python for data science, and in S5, okay, Sprint 5, I can say Sprint 5. Inside this, I'm having the files. Okay, even the notebook also I have extracted from there only. Okay, so now I need to check for what is the file name here. Car data challenge. Okay, car data challenge, and it is an Excel file. So car data dictionary, we are having car data challenge. I want, right? Car data challenge. So let me just copy the path. Copy path. Close this. Copying the path. After closing that, what we need to do? I need to paste my path over here. So I just read this cell once again. Okay, just read the cell once again. So now, what was that I'm considering RDF, right? Fine. RDF is equals to pandas dot read. I am not getting anything. I'm getting only this suggestions from the Google Colab or else Gemini. But why I'm not getting that? Previously we have seen read underscore Excel, JSON, all those things. Right? Why I'm not getting those things? Because I didn't even install the pandas. Correct? I didn't even import the pandas. So let me just run this cell first. Importing the libraries is the first main thing. Okay, importing the libraries are the first main. Then I'll run. Now if I do pd dot read underscore, I'll get all the things. Okay, if I want to do like let's say XLS, right? Excel file, I need to type Excel, then followed by in the brackets. In the brackets, I need to give inverted commas. Then the path. Okay, this is the path. Inside the content, the drive, in the my drive, I'm having AML content folder. Inside that, I'm having data science folder. Inside that, I'm having sprint file. Inside that, I'm having my car data challenge file. It's clear, right? How I'm reading the data set. Is it clear? Just drop the reactions. I won't be going back to the chat all the time. Drop the reactions, guys. Fine. So that is how I will be reading my data. Okay. So I just want to see my data. In that case, I need to type underscore df. This is how I can see my data frame, right? Okay. So I have just zoomed in. So please bear with this. Zoom out. Yeah, zoom out. Okay. Okay. Let me just close this. It will be better. Yeah. So what are all the, how many rows we are having? How many rows we are having? Let me check columns. Okay. In order to check columns, what is the command? In order to check the columns, what is the command? So car underscore df dot columns. Okay. Car df of columns. Okay. Car df of columns. I'm having these many columns. If I just want to know length, okay. Brackets I can keep and I can do length, right? So how many I'm having? 139 columns I'm having, okay. 139 columns I'm having. Okay, fine. So if I look, we are having car data challenge, car data dictionary. We are also having some dictionary also. So let's just explore this data set. What are all the things I have performed? Okay. So I have printed each and every column present in that, and then followed by I have did a group by what? Group by the manufacturer, who made that, and also considering the average city mileage. Okay, by considering the average city mileage and by considering the make, this will make my work easier, right? This will make my work very easier. How it will without like if I want to choose, if any customer, let's say your friend want to buy any car, okay, if you're having a data set, so you can consider he'll be, everyone or else he will be focusing on the city mileage only, right? What are the mileage which it is giving inside the city and outside the city? We'll be focusing on that and we'll be buying our car, right? So now I am getting the values as per that group by. Okay, so now initially what it is, what is the first line over there? So car DF group by, how to group by the makers of that particular car, and what is the how many cars, I mean what is the city mileage per kilometer per liter, and I have considered the average of the city mileage. Okay, so then what I did, I have sorted the values ascending is false. Okay, ascending is false means it will be descending. Okay, from descending means higher to lower, right? So and I have sorted it up to only show only the first 10 values. Only the first 10 values are on. Then I have stored it in the variable called sort. Then I call sort. Let's run this cell. So these are the first 10 values. We are having Maruti, Suzuki, Datsun, Renault, Mahindra, Tata, Lexus, Honda, Hyundai, Volkswagen, Fiat. So for Fiat, what is the average city mileage? It is 16. For Suzuki, Maruti Suzuki, we are having 21. Correct? So, and also we can do the plotting for the top 10. Okay, for top 10. So how we can do that? Initially, we need to mention the figure size. Okay, in order to do that, we need to write plt.figure and we need to mention the figure size like 20 into 7, and then the bar type. Okay, bar h is nothing but horizontal bar. Okay, bar h is nothing but horizontal bar. I told right on how if you want to do, we'll be sorting the index. Okay, in the bar h we'll be sorting the indexes and we'll be sorting the value. Whatever the values, what is this sort index and sort values again? This one. This one. Okay? Sort index and sort values. These were already sorted. And why did we already sort those values and we are using over here? Because we are having a huge amount of columns and a good number of rows, right? So in order to make sure we were only looking for the top 10 or the top 20, here I have mentioned the here as for sort I have considered T1 equal to head for 10. So I'm considering sort, okay? In the sort we'll having only 10 values. Right? For the 10 values only, I'm doing the bar horizontal bar plot, okay? So what are the 10 values? Fiat, Volkswagen, Honda, Lexus, Tata, Mahindra, Renault, Datsun, Maruti Suzuki, right? And average, actually the labels have been shifted and this text have been shifted. The make and average city mileage should be here. Let me just switch that, okay? Yeah. For the makers and as per the makers, their average city mileage, okay? So this is about the drawing a plot, okay? Drawing a column plot on one single column. So this was our one single column, right? This is our one single column and this is another single column which are completely under this group by. Group by will be helpful in this way, okay? Group by will be helpful in this way. Understood group by everyone? Everyone understood group by? So this is just nothing but the print statement. Maruti has the highest mileage and the least mileage is Fiat. Okay, so note price are also found in the above output and coming into task two, like I previously told, right? I have divided the things into in the task format, right? So what is task two here? What it is saying? What is the condition here? From the car data frame and in the fuel type, whatever the call I want the data which are not equals to electric. Okay. So let's see what is this value counts. What are the value counts? CarDF, and in the CarDF I want to check the fuel type. Okay, fuel type. Fuel type dot value counts. Okay, fuel type dot value counts. See, what are all the values I'm having here? I'm having petrol, diesel, CNG, hybrid, electric, CNG plus petrol. Okay, what the highest value I'm having petrol, but here what is my condition? I want to consider only values which I want to consider only the data frame which are not having the electric. Okay, so I want to completely eliminate those values. Okay, I want to completely eliminate those 14 values. So in that case, that will be my condition. It will be stored in this variable, and for that condition, I just want to show in the format of a data frame. So I have updated the data frame, and now I got the T2 data frame as without electric. Okay, without electric. So fine. Just a moment. Let me just check this. Okay, I didn't run this cell. Now let me just run this. Are we finding any electric over here? No, right? Because we want to don't consider electric vehicles. That is our condition. Okay, that is our condition. Fine. Okay, so and also we are having this just a moment. This is a T2 condition, and this is about the group by between the T2 make. What are the manufacturers in the T2 make? I don't want to consider electric. Okay, without considering the electric vehicles, I want to check the mileage. So whatever the T2 condition I'm having, I'm taking only the make column and the city mileage again, and doing the average and sorting the values sending, and then taking the first 20 values, and then this one should be on the top. Okay, yeah, consider those values, and yeah, what did I do? I did the plotting, right? Top 20 manufacturers. Again, I need to change the values over here. It should be X. It should be Y. Name T10. Okay, I didn't run this cell. Okay, so this is the top 10 or yeah, top 20 makes and top 20 mileage. Okay, again, Maruti Suzuki is leading, but which one is having the lowest? Again, the Mini Cooper. The Mini Cooper car is having the lowest mileage. What is the mileage per kilometer? It is giving 11.3 only. 11.3 only it is giving. So Fiat is somewhere over here. Under that we are having Mahindra, Nissan, Toyota, Ford, Jeep, Skoda, BMW, Premier, Volvo, Audi, and followed by Mini. Mini is having 11.3. So this is how we can keep conditions and we can draw the plots. Okay, we can draw the plots. I can consider here a different condition also. I can consider here the condition. I can say don't consider electric and also diesel. So the values will be completely low. Okay, so I can do that condition also. Okay, so what is the task 3 here? What is the task 3 I have performed here? The task 3 from the whole data frame again. I want to consider the body type and their value counts and store them in this variable. And then I want to pick the first 5 values, first 5 values as top 5. So what is the value counts I'm having? SUV as I'm having around SUV of 447. Okay, in the data frame having 447 SUVs. Sedan 333, sedan is 333, and hatchback is 316. Then coupe as 41 and MUV, okay, MUV as 39. So those are just the body type, okay, body types. So based on that, I have drawn a plot also. So let's check that. They are having less number of values for this Mini Coupe and also MUV. So we just got a lesser number of in the graph. You can see this should be Y and this is X. Okay, the make. See, mostly the body type we are having SUV, okay, and the less one of the MUV type. Multi-utility vehicles, okay. MUV is multi-utility vehicles, like the camper vans. We can say, okay, camper vans. Okay, so this is task 4, and this is according to the conditions, okay. And according to this only, you'll be working, okay. You need to know how to keep the conditions also. You need to know how to keep the conditions. By knowing the conditions only, we'll be working on the data sets, okay. When you're working on exploratory data analysis, you need to know how to apply conditions. Just see here. What is condition 1 here? I want the data frame where I want an output data frame. I want an output data frame where the car makers is Hyundai, and or the car makers are Mahindra or Renault or Skoda. Okay. So I want all this. This is my condition, and I have stored it in the condition 1 and followed by the data frame. Let me just run this. Okay, and I have drawn a pivot table. Pivot table for what? Pivot table for this T4. In T4, I'm having the values for Hyundai, Mahindra, Renault, and Skoda. Correct. I just want to consider only these makers. Okay, these makers I just want to consider. So in the T4 data frame, I want where the index will be made, okay, and the values will be city mileage kilometer. Okay, so let me just see what exactly is T4. Let me just show you. T4.head I will do. So we are having how many 5 rows for now? Let me just do the T4 shape also. I'm having 328 rows. Okay, I'm having 328 rows according to these conditions where the makers has Hyundai, Mahindra, Renault, Skoda. Combinedly, I'm having 328 values, and in that this is how the rows are, and this is about the pivot table. How to everyone knows about the pivot tables, right? It is like customizing that particular data which we are having. Customizing in the sense aggregating that, averaging that particular data which we are having. Okay. And whatever the values which we are getting, it will be the average. Okay. By default, it will do the average. Okay. By default, it will do the average. So, how is the syntax here from the data set? Consider one as an index, consider one as a value. Okay. Consider one as an index, one as a value. So if I do cylinders, I will get a different answer. Let me just try. So if I do cylinders, how exactly it is? It is in this way. So in a similar way, you can use displacement variance. I mean the variant, and also we are having the null values also for few of the columns, right? Fine. So by default, it will be doing the average only. This is about the pivot table for where we are considering the makers and also city mileage per kilometer. And this is the same pivot table where we want to consider the median. The aggregate function, the aggregation function should be median. Here, the aggregation function is mean. Here, the aggregation function is median, okay? Median. So, followed by the same pivot table, now we are considering the middlemost values. By Hyundai, again, it is around 16.38, Mahindra 16 exactly, Renault 21, and Skoda is 14, okay? This is about the median, okay? And until here we have considered about the city mileage. Until here we have considered about the city mileage. Now I want to consider highway mileage. So similarly, I will keep the highway mileage and I will check. Similarly, I will check it for the aggregation function with median. First mean, then median. Okay, first mean and then median. So now we are merging it. How to do this merging operation in the pandas? I want to merge the average. Average is what? Average is what? Average is AVG is nothing but the mean of the makers and city mileage per kilometer. Okay, mean of the makers or the city mileage per kilometer, and this is for median for city mileage kilometer. On these two columns, I want to merge. I mean, for these two data frames, I want to merge. How I want to do the merge? Based on the inner, okay, inner join. How many of you know SQL over here? How many of you know SQL? Sorry, Abhinay, I have missed your query. What are you saying? Where is cardiac is defined? For which query? Okay, Anusha, you know SQL. Okay. Everyone knows SQL? Inner join, outer join, window functions. Everyone knows it, right? So, I see only one no. Fine. So, if everyone knows, I won't be going into that SQL, okay? So, we'll just directly discuss the notebook again. So I want to do an inner join, whatever the values which are present on the make, I want to merge only those values, but how I want to merge based on the these data frames. Okay, I want to merge these two data frames, and I want them to merge on the inner join concept and based on the makers. Okay, this is about Hyundai, Mahindra, Renault, Skoda, city mileage and city mileage kilometer, and also city mileage kilometer. Okay, so this is for mean and this is for median. Okay, this is for mean and this is for median. Okay, so this is about the task, and I just did the index reset. Okay, because I will be getting only these values. What are the index values which are assigned? I will be getting those values. So I just want to reassign all the indexes from 0. So I just did reset index. And I got this. Okay, let me just run this cells. This we are done, right? So I need to run this average one and median one, and this is for highway mileage, right? Fine. So now what I did, I just drawn a plot. On what plot did I draw? I have drawn a plot based on the city mileage, mean and city mileage by median of these four makers. Okay. So this is about the plot. Okay. This is about the plot. And how I did the plot previously, what are the variable data frame I'm having that I call that variable. And mentioned dot plot followed by on what based on the make, what kind of bar you want. I want kind is the bar stacked, yes, the bar graph I want. And if you want it stacked, yes, stacked is nothing but here I will be this blue one represents the city mileage kilometer per mean, and this orange represents the city mileage kilometer per median. Okay, that is about this kind of plots. Okay, and similarly we are having this task 6. This is the last task, hopefully. Yeah. Okay, we are having all these graphs. Okay, fine. Okay, I'll just explain this. Okay. Do you want me to explain these, or else you understood the things? Guys, do you want me to explain the things, or else you understood? You got the things what we are trying to uh, go through. I'll upload that notebook and also that data set. Okay, so need not to worry. Even you people can get to explore those kind of data frames. Okay. Explain. Okay. Understanding. If I'm explaining the things, Venkat Sai and others. Understanding the things. Tomorrow what we'll be doing is we'll be directly doing a live coding for the same. Okay. Yeah. Okay. Fine. Thank you. Thank you, Yogashri. Thank you, Ghost. Thank you, Venkat Sai. Okay. So everyone is understanding, right? Fine. I'll explain all the remaining cells. Okay. So this is about it. Now coming into task 6. So what we are doing in task 6, what we are doing over here. So initially we are considering the whole data frame again. In that we are considering city mileage kilometers per liter. And we are doing filling the null values. Okay, filling the null values. Where we are rounding the null values. I mean, what are the mean which we are calculating? We are rounding it off to 2 by the decimal of this average, and we are replacing. Okay, I'll explain this. Okay, this is important, guys. Fine. So let me just check. Initially, are we literally having any null values or not? Okay. How many null values we are having? We are having 555 null values we are having. So the syntax is nothing but the data frame. Inside that I am calling a column. Then followed by that I will be calling how many null values. If it is null value, then calculate the total sum of the null values. So I'm having 555 null values. Okay. So I'll be explaining this one. Okay. So here I want to replace all the null values through mean. Okay. Let me just take a text. Delete the cell. Yeah. in this cell, I will be explaining what exactly happening in the below column. Okay, in the below column, what exactly happening is, and imputing is a term. Okay, imputing the null values with mean. Okay, with mean, and here I'm having the values like here how I'm having the values. I'm having the values in like how example is 19.22 or else like this. Correct. But but what I'm doing, I am rounding them off to round off to two decimals. Okay, two decimals. So it will be 19.22. Okay, so this is how I want all the null values to be replaced as per the mean. I want all the null values to be replaced as per the mean, and if I am getting more than three decimals, I want to round it off to two decimals. Okay, if I am getting three, I want to round it off to two. Okay, so this example right over here is not required. Let me just run. Okay, now let's check the null values for again for this cardiac. Okay, fine. 0. Okay, why it is 0? In plus equals to true is applied, right? And all the null values have been imputed by mean. And if I'm getting more than three decimals, just round it off to 2. Round 2. Okay, round 2. Understood this null value imputation? Understood the null value implementation? Understood, guys? How did I impute with mean? Understood? Any doubts in that imputation? Imputation, okay? The term is imputation. Imputing the null values or imputing the null values. Okay. So in a similar way, I have imputed the null values for highway also. For highway also I have imputed. So I will just show you. So instead of mean, I will keep median. Okay. Instead of mean, I will keep median when I want to impute the values with the median. But instead of mean and median, how to keep mode? So to keep mode, how I will be writing is mode followed by the square brackets. Okay, followed by the square brackets. Then the whole mod list I will be having. Then followed by I will be considering the initial value from the list. Okay, initial value from the list. So now I want to replace the values. How I want to replace the value by the very first frequently occurring value from the whole list. This is how I'll be replacing the values if I want to replace through mode. Okay, through mode. That is how we'll be doing. Not replace to impute. Replace is another method also. There is another method called replace also. Okay. And when we'll be doing this, when we'll be doing this replace, when we want to replace a shortcut value and we want to define it as a whole value. Okay. Let's say I'm having a column called country names. Okay, country names. I'm having a column called country names. Okay. Now I'm explaining about when to use replace. Okay. Replace. When to use this replace? I'll be having a column. What is that column? Country name. Okay, country name is the column. And for this country name, I'm having the values as US, UK, IND. Okay, now I want to replace these values and I want to show, I want to replace these values. Whatever the country name column I'm having, in that I'm having these three values, right? I want to replace these values and keep the original names. Okay, so for US, I want to keep it as United States. Okay, United States. For United Kingdom, I want to keep, or else for IND, it's India. Okay, India. So I want to keep all this value instead of this. So to do that, we will be doing replace. Okay, we can do replace. By using replace, I can change the values. I can change the values which are present inside a column, or else I can directly change the column name also. Okay, name also I can change. Okay, so this is about the replace. Okay, this is about the replace. And yeah, so again what I did, I have combined these two values. I mean, I did average, right? The average mileage I did, the average mileage as per the kilometers and as per the city mileage and the highway mileage, I have added those two values and I did by two, right? Now assigned it to car df average mileage. So let's run this cell. Yeah. And after doing the average, what I want, the car df, consider the index. See, if I keep like this, see the data frame, the car data frame, followed by this value is not present previously. Okay, that average mileage is not present previously. I have created that new column, and how to create that new column? Directly, I can call the data frame where that new column should be located at, or else it should be created at. So in that way, I can create a new column. Okay. So to create a new column, all I need to do is call the data frame in which data frame I want a new column, and then write the column name. So in that way, the column will be automatically created. Okay. So coming into pivot table, how I am doing pivot table here to know the average mileage of the vehicles. Okay, the average mileage of the vehicles. And so initially pivot table, the car data frame in that index is make and value is average. Consider values as average mileage, and I want what are the values which I am getting to round it off to zero. Okay, to round it off to zero. I mean two. Sorry, round it off to two. Then again I am storing it in the same variable, and after that I'm storing that I'm calling the same variable and sorting the values by average mileage. Whatever the average mileage I'm having, I'm sorting. Okay, and by default it will be descend whatever the values not descending or ascending, but whatever the values which I have, we'll be getting those values only. Okay, so if you see what it is by default, ascending, right? Ascending, small to big, right? So sort the values by the average mileage. So then get this value. Okay, let me just run this cell and that's it. So those are the values on the same average mileage. On the same average mileage, I have drawn a plot. Okay, I have drawn a plot. Let me just run this. So it's again the same plot. So from this plot, what I can say, the average mileage of Datsun, how much it is? It is about 25, and Maruti Suzuki followed by Maruti Suzuki and Tata. So from this plot, the insight I can draw is when compared with few of the makers, the Datsun is leading the average mileage by Maruti Suzuki and Tata, and the least average mileage performing maker is Bentley. Okay, Bentley. We can see the least performing average. The average mileage is between 10 to 15, right? It could be around 12.5 to 13, correct. So this is the insight we are writing. So writing insights is very important. Okay, identifying the insights is one good thing. So initially after identifying, writing those insights is also another important thing. Okay, writing the insights is also another important thing. Okay. So this task 7 we'll discuss tomorrow. Okay, and we'll try to do this all the plottings tomorrow by implementing all the things in a new notebook. Okay, fine. That's it for today, guys. That's it for today. Everyone understood, right? No, I'm rounding it off to two decimals. Okay, I want to consider only two decimals after that. Okay, Venkat Sai, is that clear? Yeah, rounding off is fine, but I want to round it off to how many decimals? After this, after point I want only, after dot I want only two decimals, two values. So rounding off with two. Okay. Okay, everyone, everything is clear, right? So if any queries, you can drop it in the Q&A. Okay. Okay, Venkat sir, you're saying that if I'm using Colab for explaining the things, what you need to do. So at the time when I'm explaining the things, you can just look through the syntaxes, okay, or how the syntax is playing, okay. And if you're having any doubts, you can immediately ask, and you can implement the same notebook. You can implement the same notebook, okay. You can consider the task, okay. What you will be doing is I'll be uploading these notebooks, right? So what you need to do is through Collab only, create a new notebook, upload the data set, and try to do the task which I have did. Okay, try to do the task which I have did without following the syntax. Okay, so you will be getting so many syntax errors, and you'll be understanding at what time and at what kind of syntax you'll be getting what kind of errors. Okay, so in that way it will be helpful for you. Is that clear? Yes, Venkatesh, we are discussing about what kind of analysis we can do, and as we have discussed until heat map, did we discuss heat map, guys? Heat map. So until the pre-processing we have discussed, right? So I want to make sure that you are understanding what are all the things which are involved. Okay. So I think we are done up to feature engineering and model selection. Model selection is done, right? Selecting the model. It depends on the type of the data which we are having, and based on that we will be selecting the model, right? Fine. This is it, guys. Yeah. As we are having more 2 minutes, so please let me know if you're having any other queries. If not, I'll be ending the session. Okay. Not I'll be ending the session. If no other queries, I'll be ending the session. Okay. No one is having any doubts? No, Venkatesh. I mean, no, Ganesh. There were different types of graphs. Okay. I will explain what are the different types of graphs also. Okay. What are the different types of graphs I will explain. Okay, Ganesh. Initially, we need to know what that concept is, and then we need to deep dive into that concept. Okay. Like that is how I'm explaining the thing. Initially, we have understood the things, how that concept is. Now we are seeing how the concept implementation is. Okay. Is that clear, guys? Is that clear, guys? Yeah, thank you. So anyone, any other doubts? Understood today's session? Everyone, all the 290. Okay, 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 fine. Thank you. Thank you, guys. So we'll just take leave for today, okay? So we'll again discuss the topics tomorrow. We'll implement this notebook first, and then we'll be diving into types of plots which we are having, which plot to use at what time, and I will show the different plots how to plot them. Okay, I'm having a notebook, and then followed by we'll consider a new data set and we'll do the live coding for that. Okay, tomorrow. Fine. Thank you, guys. Thanks for your time. Thank you. You may leave now. Thank you, guys. You may leave now. Okay, thank you guys. Thank you for attending the session. You may leave. All the 215 members, you may leave the session. Okay. Thank you. Thank you. I'm ending the session now. Thank you guys.